So I'll be opening this panel with a short presentation introducing the sustainability dimension of space logistics markets. So first, I'd like to start with my own definition of space sustainability for this presentation because the concept is quite broad. So let me just start with this picture. So basically, space sustainability spans across several dimensions. It's not just a single activity, but rather a continuum that connects what happens on Earth, around Earth, and in orbit. So we have what we call Space for Earth, which is everything related to space assets that directly support sustainability goals on the ground, notably through climate change monitoring, for example. Then as we move closer to the operational chain, we get into the sustainability of the space and satellite value chain itself. So this includes energy consumption, data management, ensuring that operations and infrastructures are efficient and responsible. It's also about eco-design, greener production, launch processes to reduce the environmental footprint of the space industry itself. And finally, at the core of our work, and this is also what we're going to focus on today, it's the sustainability in space. So the operational side that makes long-term space activities possible. And that combines everything related to space situational awareness, debris mitigation and removal, end-of-life management, and in-orbit servicing. So this is what we refer here as space logistics. And because without those services, sustainability of space operations won't be actually possible. So let me go into the detail of this space logistics dimensions here. So we can distinguish two complementary dimensions, the resiliency dimension and the sustainability one. On the resiliency side, we find everything related to SSA, space situational awareness. So this includes surveillance, tracking, collision prevention, so all the capabilities that ensure that we can operate safely in orbit. This notably responds to the consequences of past and ongoing unsustainable practices, and that would guarantee the continuity of operations and the protections of assets. Then we can also move to the sustainability dimension, which is here more forward-looking. So basically, this includes in-orbit servicing, the one that I mentioned before, so active debris removal, life extension, and so on. And here the focus is on extending satellite lifetime, optimizing the use of resources, and enabling future responsible operations. So now let's have a look at how this actually translates into an actual market. Who's investing, where the money is going, and which segments are really taking off for this specific segment of space logistics. So to start with, so this slide maps out what we call the space logistics ecosystems, so showing how different services on the left, are enabled by specific capabilities on the right. So it starts with access to space. So this is the foundations of all the logistics activity. From there, we have last mile delivery, extends mobility in orbit. And as we move up the value chain, life extension, repairs and upgrades, debris removal build also the core of sustainable operations. And each of these services is then paired with an enabling technology on the right. So for instance, refueling enables life extension, in-orbit assembly and manufacturing supports repairs and upgrades, and so on and so forth. And space situational awareness underpins the space removal and also overall fleet management. So now if I move on with some numbers of the market, so we can look at this market side here and specifically where the money is going. The picture is quite unbalanced, as you can see so those numbers are from between 2020 and 2024. SSA has captured almost $18 billion, which represents 87% of the total funding across the space logistics segments. if we look closer, so 95% of this funding is public, and 82 actually directly come from defense budgets. By contrast, the other segments like last mile delivery, debris removal, life extension services, innovate manufacture, they remain much more smaller, and together they account for only a fraction of the total of the investments, and they are all under $2 billion. Another key takeaway here is actually the funding mix, because SSA, so it's mainly public funded, but the other emerging services rely much more on private investments, even though they're still sometimes at quite an early stage process. Overall, what this tells us is that the commercial space sustainability market is still in its early stage. The demand is there in principle, but without a strong anchor customer, for example, like defense, which is the case for SSA, most of these activities remain technically promising, but economically could be still be fragile. Then we look at the forecast. So here we project those markets. We see the same imbalances we see in funding. It's also reflected in revenues. So here, altogether, the 5 main space logistics segments are expected to generate around $4.5 billion over the next decade. So now within this number, SSA, again, remains by far the largest segment with about $2.5 billion, which is like 55% of total revenues. It's not really surprising because, well, there's 140 million debris objects already in orbit, almost 3,000 new satellites that are expected to be launched over the next decade. So operators have an increasing need for safety and collision avoidance. The main customers, they're still the governments, which want a complete picture of the orbital environment. But we also see that operational operators, and particularly in LEO, they are starting to procure tailored tracking and optimizing services for their own fleets. The second largest segment here is life extension, so which reached close to $1 billion. So here we're seeing 2 main drivers. We have commercial geo operators that extend the life of aging satellites to delay the reinvestments, but also defense customers, and especially in the US, that explore refueling to enhance the mobility of their national security assets. So the real commercial opportunity will grow as more satellites are built with refueling interfaces. Now, let me put this into perspective with the whole space economy. So it's important to see where space logistics actually stands with the broader ecosystem. So here, the global space economy today, as we evaluate in Novaspace, is at around $600 billion, covering everything from satellite manufacturing and launch services to also downstream applications that rely on space data. Within that, the space market itself, meaning the part of the economy where the space industry actually operates directly, represents about $224 billion. So most of that is still concentrated in SATCOM, also EO, security, and SATNAV. But now when we look at space logistics, it's a completely different scale. It currently generates just about $265 million in revenue, which makes it more one of the smallest segments in the entire space market. So here I would say the key message is that the markets for space sustainability is still emerging. Most services are still at their early stage, while SSA, for example, leads thanks to clear safety and defense driver. But what it shows is that sustainability is actually gradually becoming a market. It's not yet very mature, but it builds momentum because logistics capabilities expand and government starts to create the demand that will signal the need for commercial growth. If we look at what's next, so here the idea is to see a bit what are the barriers still for this market, as well as how to overcome them with some enablers. So I'll start with the barriers first. So we see that there are mainly like 3 barriers that really stand out when we talk about what's holding back the growth of sustainable space logistics. First, it's still an early stage market in terms of maturity, as I was saying. Most technologies have been proven in concept, they work, but they're not yet at commercial scale. The return on investments are quite long, which makes it difficult to attract sustained private financing, especially when there's no clear or recurring public demand to anchor the market. Then the second the barrier would be quite fragmented interfaces and data still. So this is more of a structural issue, actually. For space logistics to work efficiently, we need spacecraft to be interoperable, whether for docking, refueling, data exchange, like it was mentioned quite a lot of time during the previous panels. But today, systems, they are mainly proprietary. SSA is fragmented across operators. We lack common standards, so without shared interfaces and data formats, it's still very hard to create economies of scales or to build a cohesive orbital service ecosystem. My last point here is actually the bottleneck of access to orbit, which is kind of like the elephant in the room still. So here, the cadence and the cost of launches, they still constrain most servicing missions. We have reusable launch systems that have helped, but access remains quite dominated by only a single major provider. And many logistics missions depend on rideshare opportunities. So that limits the flexibility, and it makes it difficult to plan regular operations in orbit. Now let me move on to a quite positive note with the enablers for this market. So basically, positive trends that are now starting to enable the emergence of sustainable space logistics. We see first an increasing technology readiness levels. So demonstrations in orbit are accelerating, there's more missions. We're also seeing the first AI-augmented data fusion systems entering operational testing, which could significantly enhance SSA capabilities and operational efficiency. Second, we have funding and revenues that are slowly picking up. There's growing interest in green investments, in public-private co-funding models, where government would help de-risk early-stage markets. So those hybrid approaches are key to bridging the gap between demonstration and actual service delivery. Thirdly, we have the market opportunity itself that is expanding. As I was saying, there's close to 300 satellites expected to be launched over the next decade. So there's demand for monitoring, for maneuvering, servicing, which is increasing. Also, defense and government needs to remain a strong driver. There's new super heavy reusable launchers that could drastically reduce the cost of in-orbit operations. And there's also a growing recognition that the cost of inaction, so of not managing debris or extending the satellite life, they may soon outweigh the cost of acting. And finally, I'll finish with the policy push, which is still very much needed and necessary. Regulators are starting to implement debris mitigation rules, life cycle assessments as well, and to encourage standardization efforts. So all of this create a more predictable and sustainable business environment. So that was the big picture for me. I thank you all for your attention, and I'll let the panel continue this discussion around the space sustainability as part of the whole space economy. Thank you very much.